Hi there, and welcome to today's webinar on how OEMs maximize their design flexibility to get to market faster, sponsored by Chief Enterprises and hosted by WebAttract. I'm Lori Dearman, Senior Webinar Producer with WebAttract, and I'll be one of your moderators for today's session. And in just a moment, we will be introducing our speakers, as today's event is about hearing from these wire harness experts as they share real-life case studies to show how adding flexibility and reliability into your power distribution module harness can get you to market faster, despite last-minute design changes, while also improving the quality of your harness. You'll also have an opportunity to have your questions answered during the Ask the Expert panel session at the end of today's program. Now, we've invited you, along with many other professionals across a variety of industries. And over the next 60 minutes, regardless of your industry segment or location, we're confident that you'll find today's webinar of value. Now, as we get started today, I would like to introduce our featured speakers. First up, we have Mike Radosta, Chief Enterprises VP of Sales and Customer Success. We'll have Mike come on with his camera. All right. Now, Mike has been in the on and off-road vehicle industry for 26 years and has extensive product and application knowledge from this experience with technical sales of electromechanical components and commercial support for his client base. He's also responsible for the new business development in North America and manages Chief's regional sales team. Mike, welcome to the webinar.
Thanks so much for having us today. Appreciate it.
All right. Also joining us today, we have Tim Buhler, Electrex Inc., Director of Engineering Services. Tim is a highly experienced research development engineering manager with a demonstrated history of working in the electrical and electronic manufacturing industry within the on and off-road vehicle industry for the past 26 years. He is skilled in operations management, failure mode and effects analysis, and schematics. He's the Director of Engineering Services for Electrex Inc., a leader in electrical system solutions since 1977, who serve a variety of OEMs, manufacturing wire harnesses, battery cables, and electrical panels. Welcome, Tim. We are so happy to have you with us here today.
Looking forward to our time together. Thanks.
All right. So at this point, we're going to have Mike and Tim turn off their cameras so as not to distract from today's content. However, they will be turning them back on for the live Q&A at the end. And at this point, we're going to take just a moment to break the ice with a quick and interactive poll. So folks, coming up on your screen will be our very first poll. What is your most difficult electrical design challenge? Is it multiple design changes? Availability of quality components? Need to reduce costs but increase functionality? Or go-to-market schedule pressure? Okay. We have here 17% saying multiple design changes, 13% availability of quality components, 42% need to reduce costs but increase functionality, and 29% saying go-to-market schedule pressure. So, Mike, Tim, any thoughts on these poll responses?
Mike, since you and I entered our markets back in the 90s, these issues have been there all along. However, the increased speed to market is driving less iterations to move from concept to production, as we see several mentioned here. They felt the need to, for our concepts to have production intent at a whole new level of rigor than I've ever seen in the past. Thus, the flexibility and durability are now critical factors at a concept level of design, Mike.
Yeah, I would agree with you, Tim, and I'd also like to say that these results really echo what I see being out in the marketplace, every day, every week, every month. What really stands out here is the need to reduce cost but increase functionality. The nice thing is that that particular focus point is very, very critical to Chief and our BRIC family of products because of the fact that we have a breadth of products that does reduce both components and devices, meaning you can consolidate multiple devices down into one BRIC system, which definitely decreases your costs based on consolidation and the labor as well when it gets into the harness side of things. So this is exactly what we see in the marketplace. So it's great to see that our philosophy is consistent with what the customers are looking for.
I agree.
All right. Well, thank you so much, gentlemen, for weighing in on that question. And At this point, I would like to pass the floor over to our speakers, Mike and Tim. So over to you.
Great, thanks, Lori. So common theme, for all of us is, this challenging landscape. It can be unfinished requirements, last minute changes, stringent testing, as we just spoke about, the pressure to reduce cost and increase functionality. So with all of this stuff that's out there in the marketplace, one of those things that we really need to understand is, what's the best way to address all of those? Tim, thoughts?
Well, I'm looking forward to sharing some good examples to speak to the flexibility, durability, and the customization that are challenges in getting to the market quicker.
Yeah, absolutely. So obviously these are buzzwords, I think, that a lot of us from the chief side, as well as our clients that are out there see, on a daily basis. And the top challenges for our customers and clients that they face today are going to be in one of these areas. And I think, the whole goal of achieving an efficient go-to-market strategy, it's critical to everybody. So I really feel that there's going to be relatable topics for every market and every customer in our discussion today.
Thank you, Mike. Yes, I am actually looking forward to sharing some good examples of this within a recent customer of ours, Venture Products, owned by the Toro Company. Now, as we worked on this SSV a couple years ago together, our goal was to minimize iterations and design changes to build reliability quicker towards a final release design within a minimal footprint as possible due to the limited size of this machine, as you see here. In the early stages of this project, we were trying to lock down the scope of the project and make some concept selection choices, what we call the CSR, concept selection review stage. At this point, we knew up to 80% of the requirements. We had a defined scope, but we were still in very much need of discovering what it was both of the user and system requirements that were still yet being fully defined. We did not know fully the loads and locations of many of the electrical components that would be required for powering the system. To keep the design moving, we loaded all the components into a schematic with concept blocks to represent the components that we did not know the final specifications of, if it was from the connector info, the type of load, etc. We also designed with at least 20% growth of new or unknown requirements that may still be added to the scope of the project, what we know now as scope creep. Either from our peer system engineer teams still defining their systems, or from marketing and user requirements that we're still always trying to get in one more thing, either it's an extra light or a USB plug, etc. In the next stage, we locked down the schematics in what we call the CDR, the concept design review. We were quickly maturing the mechanical systems and working on soft freezes so we could begin laying out the electrical system and keep components from moving around. Loads are being defined at this point. We were actually, people were quickly defining if it's going to be an LED light or a traditional incandescent bulb. Locations are being confirmed. If it's outside of the ceiling, if it is outside, it's requiring sealing. The goal in this stage is to abstract the complexity of the details away from what we call a soft freeze. We locked into the footprint of our PDM, power distribution module, so that we can actually let the mechanical team let what they need to go forward on this. So as you see here in this example, we found that the Chief Enterprise BRIC system, the Breathable and Robust Interconnection Center, as a way to handle the multiple loads and the multiple variations without us really knowing yet how much load was going to be required at that point. The BRIC 280 to BRIC Fusion centers allow for a variety of loads. As you can see here, you can have a mini to an ATM 2.8 or ATO a 6.3 to a maxi fuse. Relays can go from the Ultra 4-pin to the Micro 5-pin, or to even a mini cubed or a maxi relay with over a 50 amp opportunity there. So what was really nice is we had to lock in the footprint. Any of those options could be in any one of these modules, but yeah, it was really nice. So with the understanding there's a 360 amp max continuous current on all this.
Hey Tim, if I could jump in real quick. When you referenced the 360 max, you obviously have various applications for many OEMs. In this particular case, what was the limiting factors on the continuous rating? I mean, is it related to the module or the components or the wire? What limits that?
Yeah, what's actually nice about this BRIC system is that the material used and stuff, that's not the limiting factor. It was actually the components are the limiting factor. So you could load these up pretty heavy, even with all the maximum component loads, and still be really safe within the base structure. So that made this really nice towards our flexibility of not fully knowing yet our full loads at this point.
Thank you. Appreciate that.
Yep. In the final stage, the DDR, detailed design review, we've moved to a hard freeze in our final proto release. In the case of the SSV here, we had loads shifting around, and then when we ended up, we were able to confirm actually everything got to be moved back to a 280 footprint. And so you can see here in the far left that we were able to have the variation with, and then load the relays and fuses as we needed within, and we call it the 280 footprint because all the relays are on that 2.8 millimeters spacing, and so we were able to have some flexibility in packaging everything we needed with extra options. We were actually able to do all of this and reduce the footprint that we had initially reserved by 50%, so it really saved the mechanical team, and I know the vehicle team appreciated keeping that in the smallest footprint as we did there. Since the BRIC system used standard TE MCP terminals, which leveraged our preferred automation tooling at Electrex, that allowed us to build a production level prototype within a couple of weeks and get protos out, and we were able to hit their testing window. So this is a very successful project for us. With label and etching options, we were actually also able to bring in downstream stakeholders from tech pubs, from service teams, etc., for them to begin to develop their materials ahead of their normal project timelines as well. So flexibility was critical to the success of this design.
Very good, Tim. I appreciate you sharing all that detail for this OEM. It certainly seems like that flexibility of the component options and designs within the same space claim or footprint has allowed for quicker solutions to those last-minute changes. Not to mention the obvious ability to use off-the-shelf components in both PDMs and devices, would streamline the sourcing efforts as well. So overall, that design flexibility has allowed for scalability and a quicker go-to-market design. Wouldn't you agree?
Absolutely. That was a real the part of our whole design, and it really came out throughout the design iterations we had.
Perfect. Thank you again for sharing that.
Yeah.
So as we move forward and we talk about additional marketplace challenges, environmental requirements, stringent testing, those are things, again, that we address as well. Unfortunately, Tim, those are not the OEM electrical design requirements that are out there. There's more of them. And it goes beyond just flexibility. Can you share a few words about how you've addressed the harsh environmental conditions that your OEM customers come across?
Yeah, absolutely. So the durability, a few years ago, Ditch Witch is another longtime customer of ours who's owned also by the Toro company, had several product lines that we wanted to help them out with. The goal was to solve some deformation caused by heat issues within their current PDMs. With Tier 4 interim and final exhaust applications integrating into their machines, the ambient heating temps significantly increased and caused everything from harness conduit melting to component deformation issues due to higher current load demands. I think a lot of us on this call a lot of us have a lot of experience going to Tier 4 interim or final, seeing a lot of these type of issues. With the new system improved requirements driving higher currents, our PDMs that were satisfactory have now become overrun and hitting design limits. Engineering challenges of packaging all the extra components in the same space that we had before, even the exhaust packages now is as large as the engine packages, which caused us to add the fusing relay support where we could. In some designs, we were able to add whole new power distribution centers, but in most of the cases, it was just expanding or repackaging the current PDMs, power distribution modules, where they were at. Adding one fuse here and another there, it was a challenge to understand the impact to the topological loading of the whole system. Loads vary on maximum current draw and not always clear what was concurrent loads or not.
Tim, again, I'm going to jump in. This is similar to my last question, but I'm not sure if everybody would be up to speed on this. When you talk about those loads, the varying loads on the max current draws, what determines that? Is that another component thing, or is it limited based on the size of the wire that OEMs select or choose? What determines that max current draw?
Well, that's a great point. It is the components supporting the loads, and the continuous nature of that is really going to drive the current and the size of the wire, if it's going to increase or not. And it's also going to have a temperature impact. And so that is a concern. That's a great question.
Great, thanks for clarifying.
Yep, we underestimated in this case one of the things that the terminal underneath these components in this PDM, it's called the funnel effect. And the different types of terminals had different funnel effects that was occurring in PDMs that we were familiar with in the current design up to this point. We had been using mainly the 280 MetroPack terminal. It is not, but we quickly realized that was not the intent and design of that terminal. It was originally created for inline connectors. It's a one-sided terminal, and which the surface area of that connection against the, if it's a relay or a fuse spade, it was a current limiter. Current, as we know, current flows on the surface of a conductor. So thus we had the option to become available as underneath a new MCP terminal, the multiple contact position terminal, which allows us to have the two-sided terminal, which increases surface area, and thus the current flow increases, minimizing the funnel effect and then reducing the heat buildup. What was nice too is this terminal had the double locking tabs, which had greater retention force than a single Tang terminal in the marketplace. It is also worth noting that the IP67 requirements were often given because these PDMs are located outside the cab environment. A few features I loved about some of the things that we saw here in this side is the use of the hydrophobic vent, equalizing pressure inside of to the outside air without letting the moisture inside. What a great little piece that is, addition to this lid in this particular BRIC series. Though the BRIC has both options with and without, we always include this within our designs. We also love the compression, the silicone compression seal on the lids here, have an advantage over the radial seal that is on most PDMs today. Not only is the seal protected from damage, as often happens when the base, and thus the sealing impact is at risk, but with the CPAs, the connector position assurances, it's compressed evenly across the whole center. Another durability note is the thermoplastics engineering polymer. The PBT materials being reinforced with the glass fiber grades have a very high rigidity. We love the high mechanical strength, the high creep strength, and with very high dimensional stability. So that 360 amp max current we talked earlier is not the limiting factor here. So it's great for high temp condition applications. Implementing the BRIC solution, which embodies all the above features, has solved all our heating issues with the plastic melting and deformations with our customer. It has brought the long desired effects that all our customers have been needing, and we made this now our preferred go-to market component for us at Electrex.
Great, it's an outstanding summary, and again, I appreciate you sharing the detail. It's certainly clear that a sustainable solution is not simple. Both OEMs and the tier suppliers must consider a tremendous amount of data regarding electrical design, component layouts, as well as how that design will successfully function in different environments. Anyways, I really appreciate the summary that you gave there, Tim, on that environmental side. Thank you.
You're welcome. Mike, I do have a question for you. Thinking about customization, as I've used the BRIC examples above, how can the PDM, like the BRIC system, be customized and adopted into a design from your side?
Yeah, it's a great question. It comes up quite a bit. Obviously, we have our family of BRIC products, and we've got some new products that we'll touch base on later that are being released now. But you know, there's many times that OEMs do select off-the-shelf PDMs and components, for that matter, you know, based on their current electrical loads and vehicle features, only to discover that those features and upgrades that are being pushed through reach the upper limits of the current design. So the components will push that design off track. That could be both from the device and or the plug-in side. So in one case, we did experience added features that pushed our off-the-shelf products out of the realm of a feasibility solution for what they were trying to accommodate. So in the marketplace at that time, there was actually no PDM options that would accommodate these new requirements for the OEM that we were working with. The challenge that they faced was they had a space claim. So they had to use something that would fit into the exact same position that they had already designed, but they had upgraded electrical requirements. What we ended up doing was getting our engineering team together. We had to think outside of the box and help them provide a custom component, which was a new PDM, with a custom layout and design solution that would not affect any of the surrounding devices and the mechanical operations of that new vehicle system. So it was a challenge, but we were able to achieve it. With that being said, this particular application was related to a power window circuit that was added at the last minute for a cab that was going onto a vehicle. So the goal that we had there was to house all the newly required components to support the added features within the same space claim with a new footprint, but we had to ensure that it was in a sealed module due to the environmental conditions. So with this, it was a completely new application that we had to form into an off-the-shelf product. It was a challenge.
Yeah, sounds like it.
Yeah, but one of the things that we had to work on in doing so was we did solve the challenge by utilizing current technologies. That's PDM size. What you see on the screen here is a large frame BRIC module. We did invest in some tooling to create a new modified component layout. As you would see here, it's not a complete 84-way position module. We do have ATM cavities on the left, and we have our new customized modules on the right-hand side. We also had to consider the maximum ratings for all the components that were being put in there. Again, while at the same time maintaining, very important, the critical IP ratings, which in this case it's IP67. We also incorporated the safety features that are expected on our products, both from the TPA and the CPA standpoint. Where the added circuit breakers were put in on the end, we had to create barriers to make sure that that product was secured. That goes to the design of the component. Circuit breakers have shorter terminals. They don't go as deep into the cavities. So by adding TPAs and creating barriers, that gave our OEM the confidence level that that product would operate when it was called upon. With this, we also had to do it in a short period of time. We did it within a 12-week lead time from production to intent parts. Part of the reasons we were able to do that is we used our new CAD program, Onshape, and we actually sat down with our OEMs at the same time and walked through the designs where we can plug and play components into this module and shift them around. So it was basically an on-demand design consultation, and what you see on the screen now is what the result was. This is certainly not the first reiteration of it. It's probably about the fourth or the fifth, but we did achieve it. So with that being said, this ended up turning into being an off-the-shelf product that came from a custom solution.
I love what you shared here, Mike. This is customization, and having the agility to customize are critical for the increasing speed to get to production. Just sharing these things about flexibility, durability, and customization today has really, I think these are some of the things I've seen over the last years that really make all the difference in thinking these three factors through from the beginning on the concept level, and we get more hours on the what we call really the final design intent up on the concept beginning of that level. That's just great stuff. That's why I like working with you, Mike and Chief, and you guys got the great products and other products like this. This is critical for a lot of design. I work with a lot of my customers.
I appreciate that, Tim. I really do. Thank you.
Well, one of the new products that you just released, the BRIC Mini, leverages the flexibility and durability issues we've just been talking about. Can you walk us through just some how this can be customized to a vehicle?
Absolutely. So the BRIC Mini is our latest and greatest design, and what you can see on the screen here is our 4 customized designs that really came about through the voice of the customer. Through our interaction with our OEMs, what we ended up coming up with was 4 variations which are on the screen. We have tall brackets and short brackets. We have tall covers and short covers. That's all based on component design. As we move over and the video moves to the right-hand side, you'll definitely see where underneath we obviously have our TPAs that are also going to be incorporated. But with that being said, we do have the ability to plug in different components in different orientations. We also had 4 pins and 5 pins that it can be housed, and as we get to these last 2, you can see that right here, all of the terminals are in a linear formation where they're all going together. The last design on the right-hand side, you'll see that last fuse has a 90-degree orientation. So one of our OEMs specifically had a need to package product like that. So one of our designers, again, worked with Onshape and came up with the fact that we can rotate those terminals, which is great because there's no empty cavities. We populate all of the components inside of one package. Again, small, nimble, lightweight, and it was designed specifically based on what the customer needed in the marketplace. So it also embodies all of our BRIC family of products for hydrophobic vents, IP67, compact size, and it uses the superior terminal system. So we're really excited about the launch of the BRIC Mini. Appreciate you asking about it.
Oh yeah, I love this product, Mike. I could think of a lot of applications and solutions in months and years ahead that are going to make use of this. This will become a real preferred part for us, no doubt. Well, thanks for sharing some of these things today, Mike, and thanks for the time. So back to you, Lori.
Okay, thank you so much, Mike and Tim, for all that fantastic information. And for anyone who's registered or is attending today's event, we have a very special offer for each of you. We invite you to schedule a design consultation to maximize your design flexibility, durability, and customization. Okay. And so let's go ahead and get both of our speakers back on camera and back to the virtual microphone, if you will. And we're going to go ahead and jump in with our first question. I'm going to direct this one over to you, Mike. What are your PDM offerings?
Thanks, Lori. Great question. It's a vast question. We have a lot of products to offer. I'll do my best to provide it in a concise manner. I'm going to start with our BRIC family of products, where we do offer a 24, a 48, and an 84 position ATM cavity PDM. ATM meaning that all of those cavities are the 2.8 millimeter terminals. They all use the Tyco MCP terminal system. That family of products does have the same features across from small, medium to large, meaning they all have sealed nature. They're all IP67 sealed. They all have the availability for CPAs and TPAs. They also have the availability for tethers. We do have a service where we do laser etching, custom laser etching on the cover, which allows the OEMs to eliminate a label. Typically, labels are an additional cost. The laser etching service is a minimal cost compared to what the labels are, which is a fantastic option that a lot of our OEMs take advantage of. And then also the hydrophobic vent goes across that product line. And that is something that we use to help us achieve that IP67 rating. We also have a higher current offering in our Fusion product line. The Fusion comes in the same size frame as our large 84-way, so it's the same space claim. It uses the same off-the-shelf cover, so there's no need for an additional part number, but it gives you the ability to maximize current, so to speak. You can mix and match different devices. Devices meaning higher amperage fuses. Instead of using a lower amperage 280 fuse, you could use a 80 amp maxi fuse. Instead of using a 20 amp relay, you could go all the way up to a 70 amp maxi relay. And that's really where part of the design consultation would help, because what we would do is walk through where your circuits are, how you're wiring it, what size wire you're using, and then move from there. And really what happens is we work with what devices, what components you want to plug in, and how we can build that fusion to most optimize your design. And then obviously we did go over lastly our BRIC Mini family of products, which does utilize the 2.8 millimeter terminals. So it's more of a lower current device package, small and nimble and cost effective. So that's kind of the 30,000 foot view on what of our BRIC offerings that we have right now.
Okay, I'm going to move over to you, Tim. And the question here is, what is the best way to approach late design changes?
Sure. That happens a lot. People are always trying to either shift things around or they're trying to get a last minute requirement in. So to have ability to have some advanced room, like we talked about earlier, 20% design space or reserved capacity for future options or for future requirements like this is ideal in a PDM solution. So we always try to keep out in front of that and try to do that. Again, what's nice, like in an 84-way package brick that Mike was talking about, lots of room, lots of cavities, and so often if you're going from a 48-way to an 84-way and we're already full on a 48, the cost is so minimal. It's not much extra at all, and it just have that space, and it's not actually that much extra real estate space. So it really makes sense just sometimes just to go to that next size larger and just to have that. And you can always reduce down later if you need to for cost savings or other things, but that's what we typically do, is just try to stay ahead of it, which is a little extra growth, never maximizing where we're at right now.
Okay, back over to you, Mike, for this one. What features make the BRIC different from other options in the market?
Another great question. I'm a little bit biased, but I think everything. You know, in the PDM marketplace, there's not a standard. It's not like you can go to a SAE standard to say, hey, this is what a PDM needs to be. Yes, there is for wire and there is for different types of components, but when you put it all together, it's basically, you know, what can we put together to solve our, you know, our solution or our issue, you know, to create a solution, excuse me. So with that being said, some of the features we have that we think optimize all the technology is, number one, we use great plastics. So our base and our cover are different plastics. We use a more agile and flexible cover with a PPE/PA blend. And then from our base standpoint, it's more of a strength and rigid with our glass reinforced PBT. There's nobody else in the marketplace that uses two different plastics for base and cover. Everybody would go, we'll say, on a more economy scale where they use the exact same plastic. It's easier at the molder. We went the other way. We use a compression seal. PDMs in the marketplace now use a radial seal. Our compression seal, which allows for a very strict clasping of the cover to our base, it is different than what other people do. So when our designers took that into consideration, it is 180 degrees different from what everybody else does. There are some other vents in the marketplace. We prioritize that vent because we need that to get IP67 sealed. With that, we have done the testing. We have it documented. As I had mentioned originally, when there are not standards in the marketplace, what we did was, the chief philosophy was, we're going to create a standard. So whenever we work with a new client, we give them our application specification. Other manufacturers don't do that, and I know that from experience, from working with our clients. We will give them the documents to show what tests we ran. We can cross-pollinate that with any of their testing to do basically a gap analysis. But basically, we're creating a standard for our product to say, this is our PDM standard, because there isn't one in the marketplace. So the features from compression seal to the vents to our CPAs to our different plastics, that's all part of what we created as our standard. With that being said, we've also created a scalability. So if you go from a small to a medium to a large, scalable meaning that you can grow inside of our family, okay? And it has the same features to go from small all the way to the largest one. And even when you get to our largest frame, you've got the features and benefits of going from a 84-way 2.8 terminal to a Fusion that would incorporate 2.8, 6.3, 9.5 terminals to give you that higher ability to run more current through it. So those are some of what we feel are the features and benefits that make us different than the marketplace. And I really think that those are the reasons why we're succeeding as we are today. So I appreciate you asking.
Okay, I'm going to go over to you, Tim, on this one. And from your perspective, what are the best ways to reduce costs in wire harnessing?
So it's all about preferred parts and not using specialty parts. So if you use preferred parts like an MCP terminal, we already have automation tooling set up. So if it can just run through an auto crimping device like a Comax or something like that, automation tooling, then that allows just costs to really drop down and assembly costs to actually buying master costs and other things. So if we can keep things into a preferred packages, that is ideal. Again, if we're using a 280 footprint and instead of an ISO footprint on a micro relay, those become specialty parts. The high moving automotive parts across the industry are the 280 footprint relays. So having that kind of ability to plug those in into the harness is going to really drive down your costs. So a lot of the way I love about the Chief Design is it leads you to using preferred off-the-shelf industry parts that are actually the standard parts in the industry, and it just allows us to leverage the mass volumes and driving the costs down.
Okay, question here for you, Mike. When will the Mini be available?
BRIC Mini is coming off of production tooling right now, so it's perfect timing. In all honesty, we have been a little bit delayed. I think COVID has affected a lot of things in our environment over the past 12 to 14 months. In our case, it has pushed our timing out a little bit on the BRIC Mini. We did recently receive some of our first production tooled parts. So from a sample standpoint, we are happy to sample production intent parts. But as I had mentioned prior, we do have a standard meaning all of our products will go through a thorough testing procedure. Those testings will not be complete until the middle of the summer. So we're targeting, we'll say July 15th, I believe was the last schedule that I had seen. So certainly for form, fit, function, and we are sampling parts and we have orders in the system right now to send those parts out. We're excited to do it. But in order to get something on a production vehicle through a tier 1 harness house, that's going to be towards fourth quarter. So product would be available through completion of testing by the middle of the summer. I'm going to say July 15th, but then obviously everybody understands there's a design cycle from there where it needs to go through the process of meeting those requirements at the tier 1 and the OEM as well. So, but we're upon it. We're there now. So we're really excited about it.
All right. Tim, question here for you. What are the best ways to save time in the development stage?
Well, in the past, I've always tried to get as many of my requirements together and try to package it all. And I've realized the flaw of that is that if I lock myself into a landscape kind of a footprint and trying to put on my relays and fuses and power distribution module loading and then have these other requirements, I'm always running out of room or not having the right type of inputs. And so I've learned over the last 5 years, 6 years being at Electrex, working with hundreds of different customers, is that I'd much rather go quickly to a wired fuse relay module, not having a connectorized version like I used to use and design with. And that has really freed up the design from the engineering side on the customer side, because they can just all package that inside of the harness part number. So we can unpack the hundreds of part numbers that make up a single harness, and allows us just to put those together for them. And then we have the flexibility in that design to move and shift things around as needed. And instead of locking myself into something early on and then getting tooling around there and then getting release part numbers around that whole system and then having to change and having to add, and at the end of the day, I'm still adding an inline fuse or a inline relay just to handle the things that I just ran out of room for. So I think that there is a lot of movement in the industry to go towards, especially in the smart FLEC area where we're looking at J1939. But now that you have some other smart features, smart relays coming in, and some other things that allow for some of those things to come in, there is some options up there now today to maybe do some in-wired fusing and relays. It's a higher reliability, and it's from a DFEMA design FMEA analysis. There is actually, you score better in an in-wired solution than you do in a designed outside in a module. So this has been some of the movement that we've done at Electrex, work with our customers, and most of our customers have gone this way now. This has become the most the trend over the last, and it's just less cost, higher reliability at the end of the day. And we just get things designed much quicker from the beginning to the end.
Okay, excuse me, over to you for this one, Mike. What are your options for high voltage power distribution?
Yeah, interesting question as we get into the EV world, from could be, Tesla to the Class 8 trucks that are going that way now, to the Rivians. The limiting factor is not in our PDM. Our PDM has a very good rating. It can go up to, you could put components in there up to, 1,000 volts. But that's not the limiting factor. It goes back to the components / devices that are plugging into it, and also the wire. So unfortunately, it's kind of a short answer is to say our PDMs can handle the higher voltage applications. It depends on what components you're going to put in there. There is a limited availability of high voltage components that go into PDMs in general. Okay, that would be more of some sort of a customized solution where you've got smarts in there, where you've got, CAN processing and whatnot. But when you look at hardwired solutions, ours is equal to everybody else's in the marketplace, and the limiting factors are the components that get plugged into it.
Yeah, I agree with that, Mike. I'll just jump on that too. It's the component rating is a 32 volt, or if it's a 64 volt fuse or relay or whatever that is on that. It's the space between the actual terminals, the dielectric gap is the voltage. That's what's really the voltage rating is around. So from what we've seen too in our experience is what you just said, Mike, is we could put different variety of voltages in your PDMs. It's all about the rating of the component.
Very good.
Okay, well, those are all the questions that we have for today. Before we do wrap up, though, I'd like to go to our speakers to leave us with any closing comments, and we'll go ahead and start with you, Tim.
Well, Mike, thanks for having me today, and looking forward to continuing to work with these new products you're releasing, and excited about where the industry is going, and really excited about some of the solutions we're working on in the weeks and months and years ahead.
Yeah, I appreciate it, Tim. Thanks for all your help over the years in this past hour. It's been very plentiful, so thanks. And Lori, thanks for helping us run this today, and everybody behind the scenes at the chief side. And really, most importantly, everybody that dialed in today, all the clients and potential new clients that are on the line. So we look forward to working with you. Appreciate it.
Absolutely. And before we do sign off today, I echo the thanks to each of you for joining us. Trust that you found today to be of value. Special thanks to our distinguished panel members and, of course, our sponsor, Chief Enterprises. Most importantly, again, thanks for joining. This is Lori Dearman saying hope we see you on the next one. Bye for now.